All right, so today we're diving into something pretty cool in the world of machine learning, specifically for those self-driving cars everyone's talking about.
Yeah, it's a paper that's really turning heads. Basically, it's about teaching cars to learn how to drive, but not the way we've typically been doing it.
Not the way we've been doing it, huh? Meaning no instructors, no driving schools for robots?
Exactly. No long lectures on parallel parking for these AI drivers. It's all about ditching those explicit instructions and rewards we usually rely on.
Sounds like a pretty radical approach.
It is, and the results are quite impressive, actually.
Well, now you've got me hooked. Let's break it down. What's this new approach all about?
This paper introduces a method they call InDRiVE, and that stands for intrinsic disagreement-based reinforcement for vehicle exploration through curiosity-driven generalized world model. Catchy, right?
Yeah, sure, if you're into really long acronyms. But what does it actually mean in plain English?
In essence, they're saying we can teach a car to learn the fundamentals of driving just by making it curious about its environment.
Curious, like a car gets bored with just following lane lines.
Not bored, exactly. More like it's programmed to notice when its internal predictions about the world don't quite match up, and that disagreement becomes its motivation to explore and figure things out.
So instead of us telling the car exactly what to do and how to do it, we're letting it learn by its own internal mistakes, so to speak.
You got it. It's all about creating a more self-sufficient learning system that can adapt to new situations without needing a human programmer to handhold it through every scenario.
And that's what this InDRiVE thing is all about, this whole idea of learning through internal disagreement.
Precisely. It's a pretty big deal, actually. This paper really gets to the heart of one of the biggest challenges in autonomous driving research.
Right.
How to create a driving system that isn't limited by the very specific scenarios it's been trained on.
Right, because the real world throws all sorts of curveballs at you, literally and figuratively.
Exactly. And that's where this idea of intrinsic motivation comes in.
Okay, let's unpack that a bit. What do we mean by intrinsic motivation in this context?
Well, think of it this way. In traditional reinforcement learning, we basically reward the AI for doing what we want, like staying in the lane or avoiding obstacles. It's all about external feedback. But with intrinsic motivation, the drive to learn comes from within the AI itself. It's like its own internal reward system based on its own curiosity and desire to understand the world.
So instead of being a rule follower, it's more of an explorer.
More like a scientist, maybe. It's constantly testing its own hypotheses about how the world works, and when those hypotheses are wrong, it gets a little kick of internal reward to go figure out why.
I like that analogy. So how does that actually play out in this InDRiVE system?
They do something really clever with what they call world models.
World models, what are those?
You can think of them as the car's internal simulations of what's going to happen next, based on what it's currently seeing and what actions it's about to take. The key here is that they use multiple world models, not just one. And when those models disagree in their predictions, that's when things get interesting.
Because that disagreement means the car is uncertain about something.
Exactly. That disagreement becomes the internal reward signal. It's like the car saying, my models don't agree here. There's something I need to learn. And that drives it to explore those uncertain situations and refine its understanding of the world.
So it's not just about following rules, it's about understanding the underlying dynamics of driving.
Exactly. That's the big shift. Instead of explicitly rewarding the car for staying in the lane, we're encouraging it to understand why staying in the lane is generally a good idea.
And that leads to better decision-making in unexpected situations.
That's the hope, and the initial results seem to support that.
Well, let's dive into those results. What did they actually find?
They ran a bunch of simulations comparing InDRiVE to some of the leading methods out there like Dreamer v2 and v3. And what they found was pretty remarkable.
In what way?
Well, first off, InDRiVE achieved similar or even better performance than those other methods, but it did so with way less training data, like significantly less.
That's huge. Less training data means faster development cycles, right?
Absolutely. It could drastically reduce the time and cost of developing these systems. And here's the really interesting part. They tested InDRiVE in completely new simulated environments that it had never seen before.
Ugh.
And it still performed really well. It was able to generalize its knowledge to these new environments with very little additional training.
That's impressive. So it's not just learning a set of rules, it's learning something more fundamental about how to drive.
That seems to be the case. The intrinsic motivation seems to be pushing it towards a deeper understanding of driving dynamics.
So curiosity might actually be the key to unlocking truly intelligent autonomous driving?
It might just be. This paper is making a pretty strong case for it.
I'm curious, what kind of specific tasks do they test this system on?
They focused on two main tasks that are pretty fundamental to driving: lane following and collision avoidance. They set up these simulations where the car had to successfully navigate a course without going off the road or hitting anything.
And InDRiVE was able to learn those tasks effectively just by being curious.
Pretty much, yeah. In the beginning, they let the car just explore the environment with no specific goals in mind, just letting it learn through its internal disagreements. And then, once it had built up a good understanding of the world, they introduced the specific tasks. And even with very little task-specific training, InDRiVE was able to outperform those other methods that were trained explicitly on those tasks from the start.
That's wild. It really highlights the power of this intrinsic motivation approach.
It does, and it opens up all sorts of interesting possibilities for the future of AI development.
Before we get too carried away with the future, let's take a step back and talk about the historical context here. How do we even get to the point of exploring intrinsic motivation in AI?
It's a fascinating story, actually. If we look back at the early days of AI, especially in robotics, it was all about handcrafted features and rules. Engineers would spend countless hours trying to program every little detail of how a robot should perceive and interact with the world.
It was all very manual and labor-intensive.
Very much so. And the systems were often quite brittle, meaning they could easily break down if they encountered something unexpected.
So not exactly ideal for something as complex and unpredictable as driving.
Not at all. And that's where machine learning started to come in. With the rise of deep learning and the availability of huge data sets, we started to see a shift towards training AI systems on massive amounts of data, letting them learn patterns and relationships on their own.
So less hand coding, more letting the data do the talking.
Exactly. And that's led to some incredible breakthroughs in AI, but it also has its limitations. Training these deep learning models can be incredibly computationally expensive, and we still run into challenges when it comes to defining the right reward signals, especially for complex tasks like driving.
And that's where this idea of intrinsic motivation comes in.
Precisely. It's a way to move beyond those limitations, to create systems that are not just learning to follow rules, but learning to understand the world on a deeper level, driven by their own internal curiosity.
It's a really elegant solution.
It is, and it's not an entirely new idea either. The concept of intrinsic motivation in AI has been around for a while, inspired by research in psychology and neuroscience. We know that humans and animals are naturally curious. We're driven to explore and understand the world around us, not just because we're rewarded for it, but because it's inherently rewarding in itself.
That makes sense. And this paper is essentially trying to replicate that kind of intrinsic drive in AI systems.
Exactly. And the results are very encouraging. It suggests that we might be on the right track towards creating truly intelligent and adaptable AI systems.
It's definitely exciting to think about the possibilities. But as with any new approach, there are bound to be challenges and open questions. So let's put on our speculative hats for a moment and talk about some potential research directions that could stem from this work. Any novel notions come to mind?
Oh, absolutely. This paper is just the tip of the iceberg. One really intriguing direction would be to explore different ways of combining InDRiVE's intrinsic disagreement with other forms of intrinsic motivation.
Like what?
Well, right now, the system is mainly driven by the disagreement among its world models, which is a measure of its uncertainty about the future. But what if we also incorporated a measure of surprise? Like when something completely unexpected happens, something that none of the models predicted, that could trigger an even stronger learning signal. It's like saying to the AI, hey, pay attention, this is really important.
So combining uncertainty with surprise to create an even more potent learning cocktail.
Exactly. It could help the AI distinguish between situations where it's just uncertain because the world is inherently random versus situations where its fundamental understanding of the world is flawed.
I like that. It's like giving the AI a sense of aha moments.
Right. And another interesting avenue would be to delve deeper into the representations that the AI learns through this intrinsic exploration. They use these things called latent spaces to represent the world internally. It'd be fascinating to see if we can identify any meaningful patterns or structures within those latent spaces.
Like, could we see if the AI is spontaneously discovering concepts like left turn or acceleration even without ever being explicitly taught those things.
Exactly. It would give us a window into how the AI is building up its internal model of the world, and it could potentially lead to new insights into how we can design more effective learning algorithms.
Those are some really cool ideas. I'm already eager to see what kind of research comes out of this work.
Yeah, me too. It feels like we're on the cusp of some major breakthroughs in AI.
Well, on that optimistic note, I think it's time to wrap things up. So to summarize, this InDRiVE paper offers a really compelling vision for the future of autonomous vehicle learning, and potentially for AI in general.
Absolutely. It highlights the power of intrinsic motivation, suggesting that we can create more efficient, adaptable, and robust AI systems by tapping into the same kind of curiosity that drives human learning.
And it does so in a way that's both elegant and intuitive. No more painstakingly hand-coding every rule and reward. Just set up the right learning environment and let the AI explore and discover for itself.
It's a paradigm shift, and it's one that could have far-reaching implications, not just for self-driving cars, but for any domain where we want AI to be truly intelligent and adaptable.
Well said. And for those who want to dive deeper into the technical details, be sure to check out the original paper. We'll include a link in the show notes.
Definitely worth a read.
And as always, we want to leave you with a thought-provoking question. If intrinsic motivation is the key to unlocking true AI, what other kinds of intrinsic drives could we explore? How can we make AI not just curious, but also creative, insightful, even compassionate?
Those are the big questions that will continue to drive AI research in the years to come.
Absolutely. Thanks for joining us on this deep dive into the fascinating world of intrinsic motivation in AI. We'll see you next time on The Deep Dive.
See you then.